Thanks for coming. This is my first time in Warsaw, my first time in Poland actually, and it's been lovely. It's been great. I've been having a great time. So thanks to the organizer. Thanks to the organizers for inviting me. So today I want to talk about building people analytics. There's not really an overarching theme. It's just a bunch of small ideas that I've been thinking about the past few months, and I want to just share them. Some of you might find this topic actually really boring. I talk about data warehouses. I talk about some less sexy analytics. But I think it's still important. If Catherine yesterday talked to the ML group, I might talk to the complement, the non-ML group. So, who am I? I'm Cameron Davidson-Pilon. I'm a director of data at Shopify. Shopify, not Spotify. Shopify is a public company. We're based in Canada, but we have offices in Germany and Lithuania as well. And we're like a leading e-commerce company. We have 500,000 merchants now. I looked it up last night. Even though we're primarily English-based, we have about 400 Polish merchants. Hello. And about 90 in Warsaw, actually. I'm also the author of Bayesian Methods for Hackers, and it's an open source book about how to learn Bayesian methods from a computational point of view first, rather than a mathematical point of view. I'm also the author of Lifelines and Lifetimes. Lifelines is survival analysis. Lifetimes is lifetime value stuff. I live in Ottawa, Canada. I'm a Canadian normally. And let's try that again. That was so close. Are we back? Okay, sorry about that. And I'm currently on a Euro trip. We were just in Scotland. We're going to Paris next. Okay, so, oh yeah, and you can follow along if you want locally using this URL. Okay, so recent changes that have occurred to me professionally. So I've been at Shopify for 4.5 years now. I've helped scale the data team from 6 people when I joined to now 120 people. I was leading teams of teams. We were in charge of lots of merchant-facing products, stuff around web analytics, stuff around like conversion rate analysis. But the truth was I was getting pretty burnt out on all that. A few months ago I talked to my boss and I was just telling him how burnt out or disengaged I was. Luckily my boss was very open to this. He's had episodes like that before, so he suggested a few changes. Just a side note, if you are a manager and your employee comes to you and says they're not feeling great, listen to them and help them out. It's so important. So my boss was great about this. And what he decided was for me to join this team called People Analytics, and think of it as analytics for HR. So we're a big enough company now. We have about 3,100 employees. We can start to look internally at our own processes. Like, how are we doing in hiring? How are we doing in internal movements? What's our attrition rate? Things like that. Unfortunately, at the time, the People Analytics team, they needed some help. It was 3 of them. 2 of them were super junior. One of them was just struggling, trying to keep her head above water. So what we had was, when I joined, was we were extracting a lot of data from Google spreadsheets and Excel, reporting in operational systems, which isn't always the best thing, not really what you want to do. You can't join it with other data sets. You're limited by what that reporting system has. So think of, what's a good example? Imagine Gmail had a reporting suite. It'd be pretty garbage. So there was no scalability or sense of cumulative work. When I joined, there was nothing I could say this is what we've done in the past year, because that team had been around for a year. What we wanted was control over collection. We wanted to control where the data came from. We wanted a directed acyclic graph of data sets, so I could track the lineage of data and build this cumulative work of data sets. I want a proper data viz reporting center, because that's what the business wanted, and I wanted programmatic data curation, so being able to spot anomalies, having control, having Pythonic control over data sets and how they work and how they interact. I basically wanted to build an ETL. So there's that unsexy word, ETL. So the business wanted to answer questions like how many employees were hired last quarter? Is diversity of employees changing over time? What is the forecast for employee growth in 2018? And given some measure of attrition, attrition means like leaving the company, are we getting better or worse than last year? So ultimately, these are just like counting problems. I just needed to be really good at counting. And this keeps coming up over and over again. So this is a great slide from Monica Rogati, and I'll give you a second to sort of read it, but it's sort of the hierarchy of data needs before you can start to do AI or advanced ML. At the bottom is the fundamentals, collecting the data, and as you move up, you get more and more advanced. You sort of climb the complexity ladder. You can sort of, each time you complete one, you can go to the next one and climb that complexity ladder. This is great. I think there's one piece missing. And you're always counting. At every single step, you're counting. At the bottom, you're counting because you need to make sure that you're not dropping events when you collect. At the aggregation stage, you're either counting over time or you're computing some rate. At the top level stage, there was a great presentation just prior to this about counting, or half of it was about counting. New open source libraries devoted just to counting. There was a great blog post by Stitch Fix, came out like a few days ago, about how to compute word to vec using counting, just simple ratios, instead of going through the neural network route. So counting is always a thing we have to do. So the new challenge was I need to build a data warehouse. There's again that unsexy word. That's really, really good at counting, and then we can build on top of that. Okay, so who here has heard of double entry bookkeeping? Is this familiar? A couple? All right, sweet. So the accountants or the accounting education people kind of outed themselves. This is a term from accounting. I recently, about a few years ago, kind of caught on to this idea. So it was developed in Florence during the Renaissance, and it kind of revolutionized accounting during that time. And even today's modern principles of accounting are based on this. So the idea is simple. For every transaction from, say, account A to account B, you actually write 2 time-stamped entries into your book. One in the forward direction, one in the reverse direction. So there's the reverse direction has like a negative transfer amount. And so what happens is if I want to sum how much money is in account A, how much money goes into account A, it's going to take into account all the positive transactions, money going into A, and all the negative transactions, i.e. money going out of A. So my net total always stays the same, which makes sense because I'm just moving money around. But I can look at, if I sum up money going into A, it's going to account for the transactions going out. So that's the idea with, like, I have many accounts, I'm transferring money between them, and I write 2 entries. We can generalize this and talk about states instead of accounts. So an employee could be in a certain state. So an employee who is active, i.e. like they're employed, they are working in Toronto, Canada, they are a developer and they are a manager. They live in one state. If they're a active employee, works in Toronto, a developer, not manager, they're in a different state. And so I'm sort of saying, like, I have many, many different dimensions of what an employee could be. Each dimension has a bunch of attributes, and those define my states. And these are like accounts. Think if I have lots and lots of accounts now, and now I need to manage all these accounts. Okay, so if I have that, I can get pretty good at counting, I hope. No. It's back. Just want to give it a second. Great. Okay, so let's say this is a sample data set. Let's say I have 2 workers. I have worker 1 and worker 2. Worker 1 was hired on January 1st into a dev role. Worker 2 was hired on January 2nd into a support role, and then they moved into dev role on January 3rd. So an internal movement, if you will, in 2 hires. Okay, so how do I set up this double accounting system? Okay, so take my data set, and so I have worker, or yellow arrow denotes worker 1, and I can see I want to include this from and to columns, and these are like the previous and the next states. So when you're when you join, your prior state is turned off, like you're not active essentially. So for worker 1, I have from active is false because they're not really active at that time, or in the previous state. Ditto with the red arrow is for the second worker. They went from support to dev, and we can see that they have this from job support in the third row there. So you can kind of see the inklings of me trying to like map out directions, where things are going. The next step, it's simple. You just add this net column and it's a bunch of ones. Because we're counting, I'm going to be summing up ones, which is equivalent to counting. In the financial accounting sense, this might be a money column, but we're just counting, so I just use ones. The next step is I now take my data set. This is the double accounting part or double entry part, and I take my data set and I append it to itself, except I make some changes. So the nets always change to -1s because that's like the negative transactions, and I've also flipped the the froms and the twos. So look at the yellow arrow there. You can see in the first row, from active is false, and the second row, from active is true. Those two rows are equivalent. I've just swapped the the states. So that's like the other, like these are the negative transactions. So at the end here, I have this final data set. And it's much larger than the original, but this is my double entry bookkeeping data set. Okay, so this was a lot of work. Now I want to do something simple and answer active employees right now. So this is a SQL entry or SQL query to perform that. So I'm summing over this net column, and I want to say, give me everyone whose to active is true, which means they joined or they were hired. And let's see what happens. So the black lines are filtered out from the false or from the where clause, and notice the net change in the yellow arrows. So that's a 1 and a -1. Those are going to net out, and that's kind of the whole idea here. Those actually don't matter when it comes to this query, so they just net out, and my answer is 2 if I sum over what's remaining. Cool, like that was pretty all right. Bit more complicated. Let's look at change in support employees over time. A few additional pieces. I have a time and a group by in my select query or in my SQL query, and I have a to job equals support. So my huge multi-dimensional space of states, I'm sort of cutting 2 slices, one for support and one for to active is true. And then what that actually looks like to the query engine, it's going to filter out a bunch of things, and I'm left with this final answer. Jan 2 is 1, Jan 3 is -1. If I accumulate this, if I do like a running sum over that final column, I get essentially support employees over time. So this is I can see some individuals are excited, some individuals are bored. This is kind of just fundamental like data folding. I'm going to use this like data origami. It's just like folding data over and over again to get a result. This is like foundational to a lot of the data sets we want to work with. Let's say you work at a company and you want to look at, how I want to do a recommendation engine. I need to know how many orders were bought. I need to know who bought it and when they bought it. So this is kind of that fundamental data set you need in order to do the more advanced machine learning. I like to think of this as a data structure, actually. So it's a really good principle in software engineering to start with a good data structure, so you're not writing really complicated algorithms and code on top of that to do what you actually want it to do. So data structures will make your querying really easy, querying in both like the SQL sense and the data structure sense. So when you're looking at a data warehouse or a table, a SQL table, think of it as a data structure. How can I manipulate this table to make it the right data structure so I'm not writing these really gross, long-form SQL statements in order to get what I want? The idea to write a good data structure and not algorithms is a good software principle. I'm not sure yet if that's also a good like data science principle. I don't know if data scientists would prefer to write the algorithms or if that's more maintainable than writing a data structure. I'm not sure. Okay, so that's cool. So we built this for the HR team and they like it. They have their reporting suite now. They can answer their questions. We can do forecasts. Awesome. So let's talk about some more advanced analytics. So once we have this kind of foundational accounting data set, what can we do with it? So Survival analysis. I keep talking about survival analysis over and over again. I think because, one, I'm maintaining the open source library for Python, and so I feel like I'm the champion of it, or a champion of it. And two, I still don't see enough people using it, so I want to keep like shoving it down everyone's throats as it's a really cool technique. So it's the study of time to event. I'll give like a brief introduction to survival analysis. The study of time to event. Here are two what we call survival curves or survival functions. We look at this as for this data set. It's the lifespan of global regimes of political parties. So I split it into democratic and non-democratic regimes. This has nothing to do with people analytics. This is just a fun example. So the blue line is democratic regimes, and we can see the x-axis is the time, like how long that regime lasted for, and the y-axis is the probability it will last longer than the time. So, for example, if I look at the median of democratic regimes, so take a 0.5 and go over, it's about 4 years, which kind of makes sense. Like most democratic regimes probably exist for 4 years. A democratic regime is like Theresa May's regime, or Justin Trudeau's regime, or Bush's regime, or Obama's regime, things like that. Not surprisingly, the non-democratic regimes last a lot longer, as we can see. The median's about 8 years, but we have this super long tail of non-democratic regimes, which are kind of the monarchies, the people who exist in power for 20, 30 years. So we get a lot of details just from these two curves. We can tell a whole story about what's the expected lifespan of regimes, how likely are they to exist past 40 years or 10 years, and so on. So survival analysis is really cool. It's generally just the study of time to an event, just durations. So how does this apply to people analytics, especially within Shopify? So we can measure interesting company durations that are now top-level metrics, like time to attrition, like how long before you leave the company, time to next promotion, time to hire the candidate. If time to hire the candidate is like 3 weeks, that's maybe too fast, and other companies that have a 2-week kind of turnover will outperform you. So you want to make sure that that's not falling. I didn't mention the whole censorship event or censorship part of survival analysis too, but censorship occurs when a observation hasn't finished yet. So Justin Trudeau is the current Canadian Prime Minister. His regime hasn't ended yet. He's been in power for 2 years, 3 years. I know it's at least 3 years, but I don't know when. It could be 3 more years, it could be 10 more years, who knows. So that's censorship. These could all be censorship too. There's the current employees at your company who haven't left yet, so they're censored. What else can I say? Oh yeah, and one interesting thing too is you can be looking at, you can break down, say, time to next promotion by some diversity metrics, and you can say, like, are we promoting women at a healthy rate compared to men? So we can look at things around that too. And these are really important for HR because they don't want to be biasing their leadership team, for example. So in 2016, we did a general survey of the entire Shopify population. We had all like the employees answer some questions. There were about 70 questions in total. That was in late 2016. Since then, people have left the company. That's just natural. But now we have a cool opportunity to look back at their responses in 2016 and look at their attrition rate or the survival curves of a condition on their answers. So we looked at all 70 questions. We did a survival regression using Cox proportional hazards model and looked for significant questions that predicted or had statistical significance that people would churn based on their responses. This is one that came up. I've fudged the data, but you get the idea. So how confident do you feel about the following thing in your team? So taking risks. So clearly you can look at this and see people who aren't confident taking risks are at a higher likelihood of churning. This is really important for HR to see. So this was like great insight and analysis we gave to HR. They can now take this data and give or develop tools for the managers and leaders of Shopify to encourage risk taking or encourage encourage recognizing when someone doesn't feel comfortable taking risks. Generally, we want our attrition rate to be high, or sorry, low. If I'm looking at these curves, I want it to be high. So we'll go out of our way to make sure people feel comfortable taking these risks. There were a bunch of questions we kind of analyzed, and this was just one of them. So I'll switch to talking about conjoint analysis. Oops. And this is the study of what do humans really want. And again, dealing with people analytics, I can't just measure them. In web analytics, we're so spoiled because we have things like IP address, we have like user agent, we have refers, UTM campaigns, we have all this metadata about a visitor visiting a website. But with employees and humans, we don't have that. People don't just naturally give up, where they just came from before they arrived at your location. So we often rely on surveys. So conjoint analysis is one way to use survey methods to understand what people actually want. So the general question that came up from HR was, which benefit package do employees prefer? Benefits in tech companies, you may have noticed, are this weird kind of ratchet. You can only ever add benefits. You can't really remove them very easily. You have this entire industry adding new benefits like free lunches or unlimited vacation or whatever. And it's hard to go back. It's hard to roll back these benefits. But some benefits don't really matter to employee retention or to employee interest. And so we're trying to understand what are the core benefits that people really like. And we can't just ask them, do you like benefit X? Because on a scale of 1 to 10, because they'll just give us 10, 10, 10, 10, 10. Like no one wants to see their benefits be removed, which is totally fair. That's human nature. But we do want to know if we had to change benefits or we had to introduce new benefits, what's most effective. So this is useful for hiring strategies. A new candidate might be looking at 2 companies, and they might want to compare benefit packages given all else is equal. And we can also significantly reduce costs. If we can remove benefits that no one really cares about, that's a bonus. We can spend that money elsewhere. So let's do like a little exercise. Let's look at this survey. So would you prefer package A or B, benefit package A or B? So package A has, where's time? Okay, it's coming back. So package A has lunches, yoga, and a gym budget, and package B has lunches and some dental. Let's just say I like yoga and lunches more than dental, so I pick that. I pick package A. Next one might be a little bit different. So package A has yoga, beer, and gym. No free lunches, but package B has lunches and yoga. I love those free smoothies or whatever, so I choose package B again, or package B. Okay, so why do I like this survey method? Why am I doing this over, say, asking people on a scale of 1 to 10? So this is much more natural to how humans choose. Humans walk into a store and they want to buy lemonade. They're not going to rate lemonade between 1 and 10 and choose the higher one. They're going to take those 2 lemonades and look at the sugar content. They're going to look at the sourness, look at the brand, and then make that choice. That's a very natural human decision to make that binary choice. Secondly, it forces the respondent to do a trade-off. I can't just give them all the benefits. They have to choose and selectively choose, based on their interests, what benefit package they prefer. And thirdly, if we fit this into a regression model, which I'll get to later, we can look at the measure of importance for each benefit. So I can do more statistical techniques to get more information about what people actually like. So how do we do this? This is the conjoint analysis part. So we kind of create what are called profiles. Profile 1, for example, has lunches and yoga. 2 has lunches and dental, and so on. And then I set up surveys like I had before. I could do more than 1 profile per survey, but in this case, I just chose binary, like just 2 options. So in survey 1, it's profile A versus profile 2, and so on. So that's just, so if we go back for a second, if you had, say, n different benefits, then you might have like a combinatorial explosion, which is expected. But you can do some like interesting factorial design to sort of reduce your space and sort of figure out like a much smaller sample set. Okay, so step 2 is then get the survey results, and that's just a company-wide survey. Users will answer a few of these surveys, and they choose a bunch of different profiles. So that's just like the necessary step to collect data. Step 3 is to build that statistical model that I mentioned before. So mathematically, a profile is just a binary vector, 1 if that benefit is present, and 0 if it's not present. So unknown is a coefficient vector, I'll call it beta for now. And my model is, so the probability of choosing a profile is the dot product of the beta and the binary vector, and then I softmax it. So mathematically it looks like below. P subscript k is the probability I choose the kth profile if I'm presented with a few of them. So in our case, it's just k is going to be 1 or 2. And xk is the profile of the first or second, in our case, binary representations. And then I just softmax it, so it's like a probability. So I can fit this using either gradient descent or MCMC. A cool extension of this, and something that I'm working with, is if I had individual betas for each user, so I have a hierarchical model, and each user has their own beta, and then I can look at an individual's interest. I have to use MCMC for that, but that's all the better in my opinion. And then interpretations. So I've bolded interpreted because it's the hot word of the day, or of the week. Okay, sorry. And when that comes back, great. So the magnitude of elements in beta can be seen as a measure of the importance. So if something spikes or something's really high, the individuals or the population really likes that benefit. We're also given a correlation matrix of all the benefits, so we can look for clusters within that correlation matrix, and that itself is a really good benefit package that people really like. We also now have a framework for optimizing employee satisfaction given some budget constraint. So if finance says we can only spend X dollars per employee for their benefits, we now have a really nice linear programming exercise where we could just optimize employee satisfaction given that constraint. And so, like the previous presentation, I'm also kind of semi-announcing something today. It was already kind of open, but it's called Lifestyles, which is a way to do conjoint analysis in Python. It's built upon PyMC3. It's very pre-alpha right now. I don't even have an API for it yet. There's some docs, but it's basically just a repository for some conjoint analysis models at the moment. The idea is to eventually plug and play like any other great Python package. You give it data and it spits out the analysis, kind of the interpretations, the coefficients, the convergence results, things like that. So you can make this really easy. There's not many other libraries doing this. Actually, I can't think of any open source libraries. There's a few companies trying to like selling the software for like thousands of dollars. I know like Shopify did some or had some consultants come in and they did conjoint analysis for us. This was before my time, and it cost us like lots of money. So like there's money in this stuff too. So I think it's cool. Yeah, so I've kind of settled on the life prefix for all my packages. So there's lifelines, lifestyles, and lifetimes. So that's kind of what I'm going with. Cool. So in conclusion, just to sum things up, I think counting is easy if you build the right data structures. It's important to get that right. And then, as we saw, like counting is still so fundamental at every part of that complexity ladder. People analytics is really darn cool. If your company is big enough to support a people analytics team, check it out. I've been like thinking about different models for the company, and my current model of thinking is the company is like a small country, and I'm like the economist of that country, and I want to employ different economic models to the company. Things around like, infant mortality rate is kind of like an analogy I'm making with like attrition. Anyways. And then thirdly, there are really interesting statistical methods still being developed that aren't necessarily deep learning or advanced like neural networks. On that last point, I was kind of surprised about PyData Warsaw. There were a lot of advanced either NLP or advanced like deep learning stuff, which I think is fine. But I don't want that to become, I don't want us to ignore the other part of PyData, the other part of data science. I don't want us to see things like A/B testing as solved, because it's definitely not solved. I don't want us to see machine learning ethics as solved, because that's not solved. I don't want us to see fundamentals like data warehousing and ETLs and like cool data structures as solved. Because again, those things aren't solved. There's still like really, really hard problems there, and they're super exciting. And I don't want us to like jump the gun and get right into NLP or not NLP, deep learning, when there's still like really interesting other problems that are, I think as a community, we haven't necessarily solved yet. Cool. That's that's great time. So that's all I have. Thank you.
Thank you so much, Cameron. We have time for questions. At least a few minutes. Yeah.
I have a question about model you have described with this double bookkeeping.
Mm-hmm.
Because what made you decide to rebuild it from, I think, what would be the simplest form by having two tables with one containing your employees and the other their history? And I think that every example you have talked about could be covered by it, but probably the queries would be harder. But what made you decide to build it completely different that would be simplest SQL approach?
I think it was that the point you mentioned where the SQL would be just harder. It's easier to make a mistake when your queries are 100 lines long or more. I've seen queries that are like kilobytes long, which are just crazy. It's easy to make a mistake, so you want to push as much of that logic into the ETL portion as you can. It's easier to test there. It also allows for more flexibility, I think. It's easier to add things. I can add a new dimension. Say I wanted to add a new, are they on like leave of absence, for example? I can add that dimension much easier in this model than like having to add it to like a different kind of data set. It was just like more conceptually simple, I think. Yeah, I don't know if that answers your question, but it just made things a lot simpler, like down the line, especially for like teaching new analysts coming on board how to query this table or how to like use this table or how to use this data set. They can get up and running much quicker. So it was saving time later, I think, and saving errors later.
Next one.
So on the topic of life and on the topic of balance, you mentioned you may have had experience with like burnout and that kind of thing. And that's also something that's kind of common in this field of work in general. So any tips on thoughts on that for anyone that might be relevant?
I think it's important to, talk to your manager. They should be, as a manager, and if you are a manager, you should be very comfortable talking about that. And be very open to it. If your employee needs a couple days off, like that's fine. I probably sort of realized I was kind of approaching burnout at the right time, maybe a bit too late, but at the right time. I could sense it kind of, it's very obvious in retrospect what was happening, but at the time it just felt like maybe it's just a bad week, or maybe it's just like a bad month that I'm having. But it's not. It's probably going to keep going on. So maybe that's the advice. If you have a bad week, that's a signal. If you have 2 bad weeks, like it's probably going to continue. Don't keep putting it off. Don't keep saying like, oh, it's going to go away eventually. It's probably a problem. And then talk to your manager, talk to your lead about that. If your company's not comfortable with like you changing roles or taking like a couple days off, like the company is very self-motivated in their own interests. So like your company should be very comfortable with you taking a different role or taking time off or something.
Thank you. I can see any more hands. There's one.
Hi, could you tell us a little bit about technical infrastructure of data warehousing environment, especially what I'm interested in, as already was mentioned in the previous question. Like the solution, especially the counting table, seems kind of non-standard. It seems difficult to expose to business users so they can use them in the front-end BI system. So I'm interested how it works at your environment. What are the tools you're using and how you're exposing this analysis to business users?
Yeah, so maybe people analytics, like HR data is a particular case, unique case. We actually don't expose the raw underlying tables to end users because there's like lots of sensitive data in there. We kind of keep it to ourselves and we'll expose graphs or charts or reporting to them. So the analysts on my team are very comfortable using it, but no one else kind of deals with that. However, that's like the people analytics data warehouse. We have a whole other data team at Shopify working on like other parts of the data stack. Most end users, I think it's like a fallacy I think self-serve BI is a fallacy. I think it's never possible. And it should always be done by like a data person or someone like, BI analyst, something like that. So they'll be able to grok that kind of double entry accounting, double entry bookkeeping like pretty quickly. Most non-BI people won't. So I mean, our tech stack at Shopify we'll have the data warehouse and then Mode, which is a really great reporting SaaS company that basically it's like write SQL, get charts kind of idea. It's called Mode Analytics in front of our data warehouse, and that publishes like reports and graphs and stuff like that.
We have a last question here.
Well, it's a comment with respect to the first question, because we have certain complexity in our problem, and we can put this complexity either in the algorithm or in the data. That's one of the basic things from Donald Knuth's book, Algorithm plus data structures are equal to programs, so it's a very known fact. And in this case, I did very similar things with calculations of time, like attrition or lives, etc. And if you look at this model, it will be obvious that with this double entry bookkeeping, it's easy to see if given event should contribute to the sum or not. If you don't do it, then you don't know looking just at the event. You need to look at the event and at something before or after it. If you do double entry bookkeeping, you just look at the event and you know if it's contribution, if it's positive or negative. And it really simplifies both counting and, for example, time calculation, as it was in my case.
Right. One thing one example I didn't show off, which is super relevant, is I can now look at state transitions. So I want to know everyone who went from support to dev. That's like, I can do, if you recall the table, it's like from job equals support to job equals dev. I'm literally writing out SQL in my head. And so I know that state transition, and if I had like the raw kind of summary tables of like this person at this time was this, I have to like look back somehow in my SQL or in my something or other and ask, okay, what were they before this? And then do this really complicated kind of thing. You're basically moving all that logic into the SQL, which is just too hard, but yeah, you can be more specific with what you actually want. I think that was one of your points. Yeah.
Okay, thank you so much. One more big applause.
Thank you.